Oh, hello. You caught me in one of my guilty pleasures, calculating first and second differences. Just have some tables of values here, and I'm calculating the first differences by taking each y value and subtracting the previous y value. 22 minus 7 gives me 15. 7 minus negative 2 gives 9, and so on. Now, I like to live on the wild side, and I like to do second differences as well. So I take those first differences, and I subtract each of those from each other. 15 minus 9 gives 6. 9 minus 3 gives 6, and so on. I found something very interesting, which is the second differences were constant here. Now, I'm just working through the table of values for this one, and it looks to me like the third differences are going to be constant here. 0 minus 12 gives negative 12, and 12 minus 24 gives negative 12. Yeah, the third differences are all constant here. These were the first, then I did it a second time, now I've done it a third time, and they're all the same. Well, it just so happens that I expected this. I expected the second differences to be constant here because the equation I used had degree 2. I expected the third differences to be the same here because it was of degree 3. It was a cubic equation. And I happen to know that if the first differences are constant in a table of values, then the equation used to get that table of values was degree 1, which means it's linear. The equation for the polynomial would be y equals ax plus b, or possibly mx plus b if you're used to slope y-intercept form. The second differences were constant for my equation that had degree 2, which I like to call a quadratic. The equation for that would have been y equals ax squared plus bx plus c, not knowing what the numbers are here. Here they happened to be, the first one was 3, the last one was negative 5, and the middle one was 0. The third differences were constant when the polynomial had degree 3. That's known as a cubic. Y equals ax cubed. And you may have an x squared and an x and a constant at the end. Guess what? Fourth differences are for degree 4. We call those quartics. And they are y equals ax to the 4 plus a bunch of other stuff. And if fifth differences are constant, which will probably be rare, it is degree 5, which we call quintic. And that will be y equals ax to the 5 plus a bunch of other stuff. Do you get that? Whichever differences are constant, that's the degree of your polynomial equation. That's the highest exponent you'll see on x in the equation. We can exploit this, and we can exploit another little trick, which is the fact that the constant difference that I got here was not random. In fact, that constant difference, 6, was equal to my leading coefficient in the equation. My leading coefficient, my coefficient on the x squared here, was 3 multiplied by 2 factorial. Now 2 factorial is 2. I'll get into what it means later. But 3 times 2 gives me my 6. Just like here, my third differences, negative 12, happen to be negative 2 times 3 factorial. The constant difference you get in any of these is going to be your leading coefficient, that's the number attached to the x with the highest exponent on it, times the degree of the equation, factorial. Now, what this exclamation mark or factorial means is that if n is 1, 1 factorial is 1. Take that to mean what it says, okay? 2 factorial means you take 1 and you multiply it by 2. 3 is 1 times 2 times 3. 4 factorial is 1 times 2 times 3 times 4. This factorial means take that number and multiply it by every single number lower than it down to 1. It's just a mathematical trick that happens to work. You'll notice that 3 factorial is 1 times 2 times 3, that's 6. And my leading coefficient, negative 2, times 6 gave me my third differences. It's pretty cool. Most often what you'll be asked to do is to calculate the differences in a table, find out which one's constant. That's third differences here. Therefore, it's a cubic equation. It'll be ax cubed plus some number x squared plus some number times x plus some number. And what you can also determine is that that first coefficient, that a, plug it into this equation, plug in the differences that you get. I got negative 12 equals whatever that coefficient will turn out to be times the degree of the equation, 3 factorial. Now, I know that 3 factorial is 6, and so I can divide both sides by 6, and my leading coefficient turns out to be negative 2. Negative 2. Can I write that properly? Negative 2. Oh, look, it was. And you'll be able to determine what the leading coefficient is, whether you're given that first equation or not. Best of luck.